Okay. Now let's see the most interesting topic, which is matrix into vector. How to multiply a matrix and a vector. So suppose if I just ask you to multiply this matrix and this vector, then what you will do? Maybe you can multiply easily. How? You will say that let me multiply. This is a matrix. This is a vector. Let me multiply this particular row with this particular column, and let me get the answer. So if you multiply this particular row with this particular column, then what is the number that you will be getting here? I think you will be getting 2, right? This is 2 into 4, 2 into 1 plus 4 into 0, 2. And then you will be getting 3 into 1 plus 5 into 0, right? You will be multiplying this and this, then you will be getting 3. So isn't it? You will be getting 2, 3. That's how you multiply a matrix and a vector. So I hope that is clear to everyone. Rahil is asking, please explain what is R1. R1 is just a scalar. Okay. R1 is just a scalar. Now, please just focus here because this is going to be a very interesting topic. Okay. Have you understood this? How to multiply a matrix and vector? Then obviously we are not interested in this kind of multiplication. Otherwise, I would not have created that much hype. This particular way of multiplication is basically the connection between ax equal to b and the linearly dependent and independent whatever we have studied. Okay. So let's see a very interesting, very amazing way to multiply a matrix and a vector. Let's see. So this is the answer that you got. But let me just tell you another way. How? What will I do? I will take this vector, whatever the vector it is. I will take this vector, which is 2, 3, and I will write this vector here. Okay. I will take another vector, which is 4, 5. I will write this vector here. And I will basically say that if you want to multiply this matrix and this vector, then what you do? Take the coefficients, which means this is 1. I mean, as a coefficient, this is 1. Plus this is 0, and then you get your answer. What is the, if you do it, then 1 times this is 2, 3, and then plus 0, then you will be getting 2, 3. Isn't it? Aren't you getting the same answer that you have just got? So using that multiplication, you have got the same answer. Using this multiplication also, you have got the same answer. So earlier also you have got the same answer, which means if you are multiplying this row with this column and this row with this column, and then you will be getting 2, 3. Now I'm just going to discover another way, which is saying, you just write this vector as it is. You just write this vector as it is. Take the linear combination of these two vectors. And how you will be getting the coefficient for the linear combination? Coefficients will be this. Then this right hand side vector is just a linear combination of these two vectors. Let me give you more examples. So suppose that you want to multiply these two matrices. Oh, sorry, this matrix and this vector. Suppose you want to multiply this matrix and this vector. Then what you will do? You will say that, okay, let's just do one thing. I mean, one quick way, or one, not the quick, I will say one of the most convenient way for you till now is basically just to multiply this row and this column, and then you get this 18, and then you multiply this row in this column, you got this 6. But instead of doing this, what I'm saying, you write this vector, which is 4, 6, you write this vector here, you write another vector 7, 0, take the linear combination of these two vectors to get your answer. How to take the linear combination? Just write the coefficients from this vector, which is 1 and 2. If you do so, then this is 4 plus 17, 4 plus 14, which is 18, and then this is 6 plus 0, which is 6. Very easy, right? You can easily find out using the linear combination. Let me know if that is clear to everyone. Okay, maybe I can take more questions, right? So let's take anything. Let's suppose if I'm picking, this is 1, 2, 3, this is 5, 6, 7, this is 9, 10, 11, anything, okay? And then let's suppose I'm saying this is 1, 0, 1, or anything. I mean, you can take any vector. Let's suppose I want to multiply these two vectors. You do your way, I will be doing my way, which means you multiply this row with this column. You get your answer. Let me just tell you that how you get answer in another way. What you need to do, you need to just put all of the vectors here, and you need to take the linear combination of these all vectors, which means this will be 5, 6, 7. Okay, and then this is basically 9, 10, 11. You take the linear combination, then you ask me how you will be getting the coefficient. Coefficients will be from here, 1, 0, and then 1, right? And then 1. Then you will say this is 0, so let me just not count it. 1 plus 9 is 10. 2 plus 10 is 12. 3 plus 11 is 14. So basically 10, 12, 14 must be the answer. You can use your own way. Yeah, Subhadeep is saying he has learned this technique using one of my Go answer. Yeah, at one place in the Go, I have answered using this technique so that other people also get to know if they are not watching the lecture. So you can do your own way. You will be getting the same answer. Isn't it so amazing? Now you will say why it is amazing. I mean, anyway, I am getting the answer either in that way or in that way. But it is extremely amazing. So whatever question they are going to ask in your interview, or whatever question they you need to deal with using ax equal to b, all of this falls upon just this single method of multiplying a matrix and a vector. How? See here, earlier method, whatever you used to do, are you bringing any intuition? So you are multiplying this and this, you are not bringing any intuition here there, right? But here you are saying that on the right hand side it is basically a linear combination of these three vectors, right? So you can say that right hand side, whatever right hand side you are going to get is always a linear combination of these three vectors, isn't it? And how you will be getting the coefficient? Coefficient will be from here. So isn't it right to say that if you are writing ax equal to b, okay, this is the first time I'm writing ax equal to b. So isn't it right to say that let's suppose A is a matrix which is having some column vectors, and then whatever your x is, so whatever b you are going to get, this b, okay, this is A and there will be obviously x, this is b, whatever b you are going to get, it is a linear combination of these three vectors, isn't it? Isn't b a linear combination of these three vectors? Tell me. How you will be getting coefficients? Coefficients will be from here, right? So this b is always, this is very extremely important to understand, because this will just summarize, or this will just connect all the dots. Whatever we are going to see in ax equal to b, like it is necessary to understand this, otherwise you will not be able to understand ax equal to b. So b is linear combination of columns of A. Let me know if that is fine to everyone. Yes, I have answered that question. Mr. Singh is saying that eigenvector question. Yes, I have answered that question using this method. So anyway, but this question, that question is basically not have to be done using this method. This method is mostly for the ax equal to b. I mean, to understand what is this ax doing. But just to show that yes, this method exists, I have actually answered that question using this method. Let me know if there is any problem in this method. So let me just put that answer that I have answered on the GATEOverflow, because many of the people have talked about that. So see here, this is one of the answer that people are talking. Let me probably that put the answer here. So here also, I have answered one of the question on GATEOverflow. That is just recent question, GATE 2022 question. Here also, like I have answered in such a way that this whatever we are getting, if you just see, if you just zoom this out. So here whatever we are getting is basically a linear combination of these vectors. See, this vector I'm putting here, this vector I'm putting here, this vector here, and the coefficients will be from your this x, isn't it? So this is very important to understand this method, because this method will drive you the connection between whatever we have studied and what is the what is this ax equal to b. Let me know if there is any issue in understanding this method. Okay, so let's just continue, right? Now this ax equal to b, I can say that b is a linear combination of columns of A. So if I'm saying that this is one, it means I'm picking the first vector, picking the second vector, and I'm just adding them, right? So let's suppose someone asks you the reverse question. Let me just ask you the reverse question, which means let's suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And let's suppose someone asks you a reverse question, that they ask you the x such that you get 4, 5, 6. What you will say? Which means you need to pick the middle vector. Which means what should be your coefficient? Let me know very quickly. What should be your coefficient if you want to pick the middle vector? If you want to pick the middle vector, then your coefficient should be 0, 1, 0, isn't it? Very easy to find out the coefficients. Now, suppose for the same question, they say that The vector that you are getting at the end is 7, 8, 9. Okay, this is 7, this is 8, this is 9. What should be this vector then? What should I be writing here? Let me know. Okay, in this case, I will be writing 0, 0, 1, right? Cool. Suppose someone says, now I'm going to make it a little tricky. Suppose someone says that this is going to be, the vector that you are getting is going to be 5, 7, and 9. Then let me know what is the numbers that you should be writing. If it is going to be 5, 7, 9, then what is the numbers that you should be writing? Let me know. See here, this 5, 7, 9 is basically I have written in such a way that it is a linear combination of these two, which means this one and this one, which means you will be writing, you need to take this, you need to take this, you need to add both of this, and then this 0. Then this is 1 plus 4, 5, 7, and 9, right? Okay. Let me make it more interesting. Suppose instead of this, if I just say that if you need to have, let's suppose 6, 9, 12, then what you should be writing here? I mean, just guess it. I mean, obviously there should be some way to solve, but just guess it. I'm just saying to guess. Okay, just guess it, that what should you should be writing here, just like a puzzle. So see here, you need to pick 2 times of this, and then 1 times of this, and 0 times of this, which means this is 2 times of this. If you multiply 2 plus 4 is 6, basically 4 plus 5 is 9, and 6 plus 6 is 12. So if you need to pick 2 times of this, 1 times of this, and 0 times of this, then you will be writing 2, 1, 0, right? So yes, that is right. So Yash, Subhadeep, and Akash have given the correct answer. So actually, what I want to convey is that whatever you have at the right hand side, this right hand side is always a linear combination of the column vectors of A. So if you write A, if you write X, and then whatever you are getting here, right? If this is A, this is X, this is B. This B is always linear combination of columns. So this is what is very important to understand. Okay, let's just move further. Now suppose if I ask whether it is true or false, I give you A, I give you X, these are the columns of A. Okay, these are the columns of A. Suppose I give you A, I give you X, and I give you B, and I mean I calculate the B. So if I say that B is a linear combination of columns of A, then let me know if this is true or false. This is true, right? Because B is always a linear combination of columns of A. So that's why I can say this. Now let's move to more interesting questions, and let's actually move to Ax equal to 0 or Ax equal to B. So suppose if I say if Ax equal to 0 has some non-trivial solution, then columns of A are linearly dependent. Take your time and answer this question. This is going to be very first question which is relating actually X equal to 0 and linearly independent or dependent, right? So whatever we have studied as a linearly dependent, independent, right? And then X equal to 0, these two things we are first time going to relate. I know that most of you might not be able to get this answer correctly, but that is fine. I mean, I'm just putting it as answer, although I have just first taught, I should have taught you, then I should put it as answer, but let me just directly put it as a question. Let me know, what do you think? It is true or false? Okay, so most of you are getting true. Let's see if it is true. If Ax equal to 0 has some non-trivial solution, what does this mean? Let's just first understand what is Ax equal to 0. Ax equal to 0 is basically, this is A, this is X, and then this is 0, right? Equal to this, everything is 0. So here, what I'm saying here is that let's suppose this vector is, let's suppose A1, small a1, this vector is small a2, this vector is small a3. Okay, these coefficients could be x1, x2, x3, or c1, c2, c3, anything. Let's suppose this is A, this is X, this is 0. Let me know if the writing is fine to everyone. I mean, the notations are fine. A1 is not a scalar. A1 is a vector. That's why I'm just writing it like that. I mean, just writing the arrows. This is a vector, this is a vector, this is a vector, these three are scalars, right? The notations are fine to everyone. Now, Now, the way we have just multiplied, can you say that the C1 A1, because you need to take A1 A2 A3 linear combination and the coefficients will be coming from here. Can I say C1 A1 plus C2 A2 plus C3 A3 is equal to this vector 0? Or maybe let me just go to the next page. Here, what I'm saying is basically this C1 into A1 because that's the way we multiply, right? C3 into A3 is equal to 0, 0, 0, right? Is this okay to everyone? By writing this matrix notation using this linear combination notation. And that's how actually both of things are related. This is just a matrix notation. This is notation of linear combination, right? And that's where the both of the things are relating to each other. Now, if I say that Ax equal to 0 has some non-trivial solution. If I'm saying some non-trivial, matlab, I'm saying that there is some non-zero that also satisfy, right? There is some non-zero Ci which also satisfy, which means that there is some non-zero satisfy. See, if this kind of equation is given to me, then I always ask a question: do you have some non-zero satisfy? Non-zero Ci? Do you have some non-zero Ci? That's the question that I always ask, right? Some non-zero. And it is given in the question that yes, they have the non-zero Ci, right? It is given in the question. They are saying that there exists a non-trivial solution for x equal to 0. X is what? X is just C1, C2, C3, right? There exists some non-trivial, which means that Ci is non-zero. Then they will give me the Ci. If they give me the Ci, I can represent one of the vector as a linear combination of other vectors. It means that A1, A2, A3 are linearly dependent. Let me know if you have understood this particular question or not. Yes, Jigar. So Jigar Patel is saying that means we have Ci which is not equal to 0. Yes, that's very nice observation. Right? Everyone has understood this. What they are saying that there is some non-trivial solution. It means there is some non-zero Ci. It means first I need to represent. See, you should be extremely comfortable in writing one from another. Either they give you the matrix notation, maybe you need to convert to this. They maybe giving you this, and then maybe you need to convert to this. Okay, so you should be extremely comfortable. I mean, there should not be any differentiation to you if you are writing either matrix Ax equal to 0 or you are writing as a linear combination of columns of A. Okay. So that's where these dots are getting connected. That Ax equal to 0 is nothing but a linear combination of columns of A. Right? Ax is nothing but a linear combination of columns of A. If you write Ax, you can say this is nothing. This is same as linear combination of columns of A. So I hope this question is clear because they are saying non-trivial solution, which means indirectly they are saying that there is a non-zero Ci. Okay, I need to know कि non-zero है कि नहीं. Zero से मुझे फर्क नहीं पड़ता, केवल मुझे zero के बारे में information दे रहे हो, non-zero के बारे में नहीं बता रहे हो, तो I do not care. You should be telling about the non-zero. They are saying कि non-zero है. It means कि मैं कोई तो अगर जो भी non-zero है मैं उसके corresponding अगर ये वाला non-zero है तो I can represent A1, and which means they are linearly dependent. So what they are saying, then columns of A are linearly dependent. Then answer is yes. That's why it is true. Okay. Hope that is okay to everyone. Okay. Now someone is saying, can we visualize it using a straight line in 2D? If the vectors are in R2, then only you can do it. If vectors are not in R2, then it is not easy to visualize it. You cannot visualize the things which are whenever you go more than 3D, you cannot visualize it. Okay. Can we say trivial solution? Cool. Now let's just understand it more. So Ax equal to 0 has some solution. Then can you say about the linear dependency of the columns? So suppose if I just give you this information, okay, if I just ask you this question that Ax equal to 0 has some solution, then what can you say about the linear dependency of column? Which means that I say that this equation Ax equal to 0 has some solution means immediately means that this equation, right? This equation, writing this equation and Ax equal to 0 is actually same. So if they say Ax equal to 0, you should mean that they are basically writing this equation, right? They are saying this equation is having some solution. Okay. Then what can you say about the linear dependency? Whether the columns are linearly dependent or independent. Let me know. Exactly. So ax equal to 0 always has some solution, right? They are saying they have some solution. वो तो मुझे भी पता है ना कि some solution है. C1 equal to 0, C2 equal to 0, C2, C3 equal to 0 है तो सही solution. मतलब what they are telling me, they are not telling me anything new, right? I also know कि वो solution तो है ही. X equal to 0 का एक solution तो होता ही है, x equal to 0, right? Ax equal to 0 always have the trivial solution which is x equal to 0. They are saying they have some solution. So what? I mean, वो तो मुझे ही पता है कि वो solution है. They should tell me whether there is only trivial solution. There is some non-trivial solution like that. मतलब कुछ तो extra पता है ना. कुछ solution है वो तो पता है, सबको पता है, right? Okay. No, let me just go here. Let me just ask this question in another way. Ax equal to 0 has some non-trivial solution. If they say non-trivial, okay? If they say non-trivial, then this question is little making some sense. If they are saying non-trivial, it means they are saying the Ci is non-zero है. That means linearly independent है. तो linearly dependent है. अगर वो non-trivial बोलते हैं तो ही है. अगर वो नहीं बोल रहे हैं, then I don't know. I don't know. Okay. If they are saying non-trivial, अगर वो बोल रहे हैं कि some non-trivial solution है, then it makes some sense. They are saying some trivial, some solution, तो वो तो trivial भी हो सकता है ना. Then it is not very good reasoning. I mean, very good statement basically. Okay, this statement basically is not bringing me any information. They are saying कुछ solution है, वो तो मुझे भी पता है कि कुछ solution है. X equal to 0 तो है ही ना solution. X equal to 0 तो कुछ solution है ही. Okay. So till now, let me just summarize everything before we go further, because now we are entering into the world of linear algebra. Okay, we are actually entering now. So we have just built the basics. We now know how to multiply a matrix, a vector. So basically, we know what is a linearly dependent and linearly independent, right? We know we cannot have more than n linearly independent vectors in Rn. I mean, till now अभी तक के लिए थोड़ा ऑनेस्टली रटा ही है ये वाला स्टेटमेंट, थोड़ा बाई हार्ट ही किया है. मतलब कि R2 में 2 से ज़्यादा नहीं हो सकते, राइट? R2 में अगर आप 2 से ज़्यादा ले लोगे तो फिर रैंक ही इनकी मतलब लाइक लेस देन इक्वल टू 2 होती है. तो उतना तो थोड़ा बेसिक इंट्यूशन तो पता है, बट अभी तक के लिए थोड़ा रटा हुआ है ना. सेकंड स्टेटमेंट का मैंने कोई प्रूफ नहीं दिया है क्योंकि अभी मैं नहीं दे सकता उसका प्रूफ. तो फर्स्ट वी नो कि लीनियरली डिपेंडेंट इंडिपेंडेंट क्या होता है. मैट्रिक्स को वेक्टर से कैसे मल्टीप्लाई करना होता है वो भी हमें पता है. एंड वी ऑल्सो नो कि R2 में या फिर Rn में मोर देन n नहीं हो सकते लीनियरली डिपेंडेंट की अगर बात करें तो, राइट? तो दिस थिंग्स वी नो. Now we are entering into the world of linear algebra with the basic information that we know. Okay, so this is just a summary. मतलब अभी तक ये बस summary, मतलब summary in the sense कि ये हमें पता है. I think ये points obvious हैं. Let me know if there is any doubt in this. Okay, linear dependent independent क्या होता है वो हमें पता है. हमें equation दी जाएगी, like they will give us some equation, and then we will ask कि वो एक CI है कि नहीं इसमें, right? At least do you have one CI or not? That whole story you know. Okay. Cool. Now let's just move further. Suppose they give you this matrix, this vector, okay, and then they ask you that what you should be filling in place of x, y, z, w. Okay, let's just have an exercise. So what you will say, if I just give you a hint कि इन दोनों के summation से you are getting this thing, then what you will be answering? Let me know your answer. Yeah, it is very easy, right? It is basically you are saying 1 1, you can take this, and you do not need these things. So 1 1 0 0, right? Very easy. No, I'm just asking this x, y, z, w. It is 1 1 z, w. Okay, 1 1 0 0. Now in gate, only mainly two things are there. Ax equal to b and eigenvalues, eigenvectors. Obviously determinant and all of this little bit things are also there. How to find determinant and all. So I hope that you know how to find the determinants, right? Mainly we will be seeing Ax equal to b and eigenvalues, eigenvector. So now we are going to enter into the world of linear algebra. So remember, I have just told you that we have asked this question, that how to find the linear combination of the vectors. So I think that that way was very easy for us, that how to find the linear combination of the vectors. Finding the linear combination of the vectors was very easy. Now we are going to flip this question. What we are going to say, that instead of asking that how to find the linear combination of the vectors, I am just going to say that okay, the linear combination will be given to you. How to find the coefficients? That's going to be an interesting question, isn't it? That's what Ax equal to B says. So this is just a, this is a, these are the just x, these are x, this is b. So you need to find this x, right? I mean, see, given this a and x, you can find definitely b. I mean, there is nothing in this, and that's what we did, right? Given this is a, this is x, you can definitely find b. There is nothing fancy in this. But now let me ask a reverse question, or let me just flip this question a little bit. Instead of giving you the right hand side b, I mean, instead of asking you right hand side b, I will be giving the right hand side b, and then I will be asking the coefficient. That's what ax equal to b says, isn't it? So I hope that is clear to everyone. Let me know if you have any doubt. Okay, so let's just get started now. Let's just move towards solving system of linear equations. This is going to be very interesting topic, because now you know all the basics. Now I do not have to put my energy in explaining the basics, which means a और x का multiply कैसे करना है. It is actually in linear algebra it is 2 into 2. I mean not 2 into 2, but yeah, मतलब like linear algebra में there's a basic thing कि a into x कैसे करना है. Now I told you what is a into x. Now whatever I'm going to tell you is very basic and very interesting things, because now I do not need to tell you the basic. Now we can go in very good flow. Okay. Thank you everyone. Thank you. Take care.